Alrighty, what's up, folks? Coming in through with our new notes, dude. It's good to see you if you are coming here to look at this video. So, let's take a look at similarity again, but this time we're getting a new flavor with right triangles. Let's take a look at it. So, this is going to be very formulaic in nature. I don't want you to feel any type of way when you start it, but I would very much advise you follow the process from our notes and keep up with it. All right, let's take a look. All right, before we get into any shapes, we got to start talking about a new thing, which is what is the geometric mean? So, the geometric mean is for any two positive numbers, A and B, the geometric mean is the positive number x such that A over x is equal to x over b. Now, that may seem like a lot, but just hold on. It's going to be all right. So, things to know. X is equal to whatever the square root of A times B is. Now, what we're going to do, you're going to get two numbers to be asked what the geometric mean is. So, for this first one, we have 4 and 9. Just like how we have in this formula A over X equals X over B, we're going to set up this same little proportion, okay? Now, when we do this, we are going to cross multiply just like we did before. So we got 4 times 9, and we have X times X. Now, X times X is X squared. 4 times 9 is 36. And just like how we've solved for X in the past, we had to go through and deal with what is the opposite of what's currently happening to the X. So the opposite of X squared is us taking the square root of X. Sorry, that symbol came off a little bit. All right, let me fix that. There we go. All right, so if you take the square root of X squared, you are undoing the exponent here, this 2, which leaves us with X, like how we would want to go through to solve. Now, we did this on one side. We also had to do this on the other side. Sorry, folks, my mouse needs to be a little bit more calibrated, I guess. All right, so we take the square root of both sides. Let's get this symbol up. Boom. All right, now the square root of 36, because it's a perfect square, is in fact going to be 6. So at the end of it, x will equal 6. Now we have to be aware. Sometimes you might have some decimals. Sometimes you might have some problems, but don't freak out, okay? Now, things to be aware of. This right here, your x is always going to be equal to whatever the square root of a times b is. So honestly, you don't have to go through and write everything out like how I did. This will always be what we are dealing with for the geometric mean. So if I were going to go through and hit the second problem here, we got 15 over x equals x over 20. Now, you might worry, how am I going to set this up right? What if I mess this up? It's not that big of a deal. Things to know is that these two right here are always going to be in the same places. These two are interchangeable. It really doesn't matter if you put 15 here or 20 here. They're going to be multiplied together. So don't freak out, okay? Now, we're going to be taking the square root of whatever a times b is. So 15 times 20. So I know 15 times 2, that's 300, not 3, 300, 30. And then I go through and put that 0 on it, so it's 300. Now, 300 simplifies into two different things. You could have this in radical form with 10 the square root of 3, or you can give me the decimal form with 17.3. So either one will be perfectly fine for this. I'm probably going to stick more to the decimal side of this because we're going to deal with radicals when we get more towards trigonometry. So Oh, look at you. Sorry, my cat's here, y'all. So let's take a look at some new stuff with similarity. No, you can. All right. So similar right triangles. The altitude to the hypotenuse of a right triangle forms two triangles that are similar to each other and the original triangle. Now, that is quite a lot of stuff to see the first time. If you don't remember what an altitude is, it's in our glossary for chapter one. So this is a line that comes from one side of our triangle to the vertex of another side and makes a right angle. So let's look at this little quick example. If ABC is a right triangle, which we have right here, with a right angle at ABC, which is right here where B's at, and BD is the altitude to the hypotenuse. So when I say altitude, we have this line here that comes from B over to the other side and stops at a right angle. Now, this shape here sets up a couple different things. It sets up two new triangles inside of this big one. And based off of this, we have a few things. First off, ABC is going to be similar to several triangles that we have created now. The first one being this top one here. This one goes from A to B to D. It has a right triangle, just like how we had originally. We had that right angle over there on D. So if I wanted to pull this out to the side, I can take a look at what I am rocking with. So here's a DB. I know that our hypotenuse, which is the side that's opposite the right angle, which is AB, is the same thing as what we have over here, AC. We see the right angle D, just like how we see the right angle B. So we would say that triangle ABC is similar to ADB. Now, if we continue on, there's another triangle that we have here. Let's look at this bottom one. So, dragging this over to the side. Right now, it's not facing the same way how we would like to. So, let's flip it around a little to right here. So, just like before, we see we have a right angle at D. And we also have another new hypotenuse, which is the side opposite again from the right angle. So just like how we had AB as our hypotenuse here, and in the original triangle AC, we know what corresponds based off of where these things are positioned at. So ABC is similar to, instead of ADB, for our last one, we have this one here, BDC. See, if I look at AC, which is the side where our hypotenuse at, in the new triangle, BC corresponds exactly in the same way, going from up top to down here and not touching this angle. And just like how B was in the middle here where the right angle was, D's in the middle again where the right angle is in these two new triangles. Now, along with these triangles, these two small ones being similar to our large one where we started off with, these two triangles here are also similar. See, they both have D in common, and they both have a hypotenuse, aka the side that's opposite that right angle. So we can say that ADB is similar to BDC. So when we go through and deal with this, we are going to be using these to find any missing sides and or prove their similarity. So let's take a look at some new information. All right. New information we got is the geometric mean altitude theorem. Let's talk about it. The altitude to the hypotenuse of a right triangle divides the hypotenuse into two segments. The length of that altitude is the geometric mean of the lengths of the two segments. So in this new little formula that we're going to have, we have these two sides here. CD, which is a part of the hypotenuse from the original shape. That is going to be put over the altitude here, which is BD. Now, over here on the other side of our proportion, we have our altitude, which is BD again, over the other part of the hypotenuse. So this is the same formula that we had for the geometric mean, just put in terms of what we have here for any given triangle that we had. So we're going to use this as a guideline. It's always going to work out like this. We're not going to deviate from this right now. Okay. So we can use this formula here to set up anything that we're rocking with to find any missing sides. So let's look at a quick example. Right here, they give us a couple things. I see they gave us the altitude. They gave us one part of the hypotenuse, but we're missing the other part. So we're going to use this formula to set this up and knock it down. So our proportion is our altitude over here on the top and the bottom of both of these fractions, and one part of the hypotenuse here and the other part of the hypotenuse here. So I cross multiply these two. When I cross multiply over here, I end up with 4x equals 36. Now, just like we've done in the past, we got to get x by itself. So we got to divide by 4 because we were multiplying by 4. Dividing by 4 is going to knock out the 4's over here, leaving you with just x. And then you have 36 divided by 4, which gives us a solution of 9. Now, if I were to go through and put this back in there, this will work out for not only the formula, but it'll also work out for me to go through and figure out anything else involving this triangle in terms of similarity. Now, along with this formula, we also have the geometric mean leg theorem. Now, this one's a little different, but be aware we use these as guidelines to set up these different formulas and solve our problems. So, the altitude of a hypotenuse for this new definition divides the hypotenuse into two segments. The length of each leg of this right triangle is the geometric mean to the lengths of the hypotenuse and the segment of the hypotenuse that is adjacent to the leg. If you don't remember what the word adjacent means next to. So depending on which leg we're looking at, aka the sides here that are not the hypotenuse, we are going to have two different formulas. Over here on the left, we have the whole hypotenuse, which is CA or AC. That is going to be set up over this leg. This leg here is AB. Now, just like before, we always had what's in the denominator here show up in the numerator here. So we have AB one more time. And then in the denominator of this other fraction, we're going to have this small part here of the hypotenuse next to AB, which is AB. Now, this is for if you had to go through and find this side here of the right triangle. If you had to find this side, we set up things a little bit different. So let's take a look. We still use the hypotenuse, AC again, but this time we're looking for this leg, which is BC. Now, BC is also going to show up in the numerator here, and we're going to use the part of the hypotenuse which is closest to BC or adjacent to BC, which is CD. Now, depending on what you are given, you're going to use one of these two formulas if they're asking for a side outside of the triangle. Now, don't freak out. This is not made for you to go through and just do it willy-nilly. You got to refer to the notes. So let's take a look at some examples. All right, this time we're looking for a side which is one of our legs. We're given the lengths on the hypotenuse. We're looking for a leg. Let's go through and set this up. So this is pretty similar to what we had over here. Okay. So we have in our proportion 12, which is what the whole hypotenuse is here on the bottom, because we got 3 plus 9, over x, which is our side here we're looking for. X is going to be on the top over here. And in the bottom, we have the part of the hypotenuse that's closest to x. From here, we got to go through and cross multiply. Now, when we cross multiply this, remember, we're going to end up probably getting a decimal when we have to take the square root. Don't freak out. It's not that deep. You will need a calculator, though. So when we cross multiply, I am looking at x times x. We had to get rid of that by taking the square root, which is where this radical is starting to pop up. Now, originally, you had 9 times 12. 9 times 12 is 108. When you take the square root of 108, it's a decimal. That decimal is around 10.4. You can give me the radical form, which our calculator will most likely give you, or you can go through and give me the decimal form. Either one will be acceptable. Now, am I aware this is a lot of information? Yes. But if you need to go back and refer to the notes, or if you need to go back and get a refresher, go back. It's perfectly fine. All right, let's take a look at a couple of examples. We got stuff from the Let's Practice. Let's see. I think this is on the. I think this some of this is the I do it and we do it. The other stuff is what's on the bottom. So let's get into some stuff. All right, over here on the top left, we got the altitude, which is our x. When we're using the altitude, we're going to have to use the first formula that we looked at. Let's go through and just review that one more time. So when we're using the altitude as our missing part, this is what we are going to be messing with, the mean altitude theorem. Okay? Sorry, I had to go through and click a little bit. So we're going to set this up just like this. All right, let's go back to our problem. So our missing part is x. So that altitude is going to be the x. It shows up in two places, in the denominator here, the numerator here. The 9 and the 6, those come into the other two parts. So I have to go through and do net cross multiplication, which will go through and give us 9 times 6 and x times x. Now, x times x gives us x squared equals, and we got over here 54. Now, when we go through and finish solving our math, sorry, I got to go through and erase that. We have to take the square root of x squared, which is just x. So x will be equal to the square root of 54. There are two answers that you can give me. You can give me the radical form from this, which is 3 square root of 6, or you can give me the decimal form, which is 7.3. Quite a bit of stuff. I'm not going to go through and act like it's not, but go slow. It's fine. We'll go through and review it when we come in class. All right, next one. They give us the altitude again. So that means that we got to go through and use the same type of deal as we did over here. All right. So our proportion is set up as x over 60, because we're missing the part of the hypotenuse here, is equal to 60 over 25. So I cross multiply. I got 60 times 60. That's going to be, let's write that down. We got 360 and another 0. Boom. So we got 3,600 equals 25x. We got to divide both sides here by 25. So let's go through and do that. This gives us a nice solid 144 when we do that. Takes a little bit, but it's all right. Okay, so What we have over here on the next one is something that we're going to have to use the Pythagorean theorem. I don't know if you remember the Pythagorean theorem, but as an aside, let's just go through and get that written up for you, okay? The Pythagorean theorem is when you got a right triangle. So I'm going to draw this right up top because I need some space. When you got a right triangle, you have two sides here. One of the side, ugh, can't even write that. That's terrible. Do 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 do. There you go. So over here we have two sides. We have on the right triangle A and B next to our right angle. Across from the right angle we have C, which is the hypotenuse. The Pythagorean theorem, if you don't remember, is A squared plus B squared equals C squared. So what we have here are two aspects of using the Pythagorean theorem. We're going to have to at least use it one time to figure out one of these two parts of the hypotenuse because we can't really go with two unknowns into this. So let's go through and use some math. On this triangle, they give us two parts here that we can use for the Pythagorean theorem. They give us the two parts that are attached to our right angle. So we have over here 15, that's B. 20, that's A. Or you can switch it around and say this is A, this is B. It's interchangeable. Now, we're using this to find our side here where X and Y is at. This side here is C. So, first setting up, we use 15 squared plus 20 squared gives us C squared. When we go through and set up the math, this gives us as C as 25. Now, as C is 25, we can go through and use it to find not only X, but Y. So, I'm going to be using the geometric leg theorem for this. If you don't remember the geometric leg theorem, let's go back one more time. We have either the hypotenuse over the leg that we're looking for, and then we have on the other side the leg we're looking for over the part of the hypotenuse that's closest to it. In the other end, if we're looking for the other leg, we have the hypotenuse over that leg is equal to the leg over that part of the hypotenuse that is closest to it. So let's get back over to that last one. All right. So I want to go through and find X first. My formula starts off as 25, the hypotenuse, over 15 is equal to 15 over X. 15 being that leg that we had. So when we go through and cross multiply and solve for it, I get that my X is going to be 9. And if I know what the X is, I can go through and subtract that from C, 25, to get the other thing, Y, which is 16. Now, I've gone through, I've done most of the examples for you. I'm going to go through and give you at least the first part of this last one. You're going to have to go and knock it out, people. So, you will most likely need to use the geometric leg theorem, just like we just did. Here's the beginning of it, and I'll catch you when we come back in class. Thanks for watching. Hope y'all have a good rest of your day.